Hello everyone, my name is Bunjeju with metric number of 22030482. Today I'm going to present the KNJ6233 Computer Aided Design and Application Individual Project. So this presentation will be separated into several parts, which is introduction, methodology, design of the product, and finally conclusion. So let me begin my presentation. So my company name is Luna Design Innovation. And Luna Design Innovation is a dynamic and forward-thinking product design company. So it is established in year 2010, and we have consistently delivered cutting-edge product design solutions that bridge the gap between functionality and aesthetic. So our team of talented designer, engineer, and creative mind collaborate tirelessly to bring idea to life and create product that resonate with our clients and end user alike. So our future company product is the prosthetic leg. This is because the value of the global prosthetic leg market is increasing due to the demographic shift and increasing demand for advanced prosthetic limb. And we have identified a growing need for prosthetic leg that not only offer improved mobility but also suitable to individual lifestyle and preference. So our goal is to create the prosthetic leg solution that excel in comfort, functionality, and adaptability. So now we move on to the methodology. So in methodology part, it consists of component analysis, interaction analysis, functional analysis, cause and effect diagram, and trace 40 principle is also used in this study. So this is the component analysis of the project. So the prosthetic leg comprise of several important components such as socket, connecting shaft, knee joint, and foot. So the socket is used to attach to the amputee residual limb, offer a secure and comfortable fit while effectively distributing the weight and force. So the connecting shaft is used to connect the socket and the knee joint and also the foot. So moving further down the leg, we encounter the prosthetic foot, which is available in various designs tailored to specific needs. And this design includes standard feet for walking, specialized running feet, and those crafted for particular activity. So next is the interaction analysis. So interaction analysis is conducted to examine how each component interact with the environment, humidity, and ground, and how this interaction affect the product, which is the log in this case. So based on this figure, the connecting shaft is the main component to hold the knee joint and socket together, while foot is the component to move the log, which is the user. And socket is used to support the log and is in direct contact with the amputee limb. And knee joint is affected by humidity. This is because it is exposed to environmental condition, including humidity. So interaction analysis is conducted to examine how each component interact with the environment, humidity, and ground, and how this interaction affect the product, which is the log in this case. So based on this figure, the connecting shaft is the main component to hold the knee joint and socket together, while foot is the component to move the log, which is the user. And socket is used to support the log and is in direct contact with the amputee limb. And knee joint is affected by humidity. This is because it is exposed to environmental condition, including humidity, which can affect the lubrication and functionality. And high humidity can affect the lubrication and friction within the knee joint, and potentially influencing its performance and durability. And next, the condition of the foot component significantly affect how the prosthetic leg distribute and manage the load applied during various activity. Furthermore, the foot interact directly with the ground and it provides the stability, shock absorption, and propulsion during walking or other activity. However, the foot is restricted to the environmental condition and may encounter variation in humidity, which can affect its material and performance as well. And in this case, the high humidity can affect the material and the grip of the foot, and hence affecting the user's stability and balance. And the next is the functional analysis. So functional analysis involve examining how its components interact with each other and with the supersystem component such as environment, humidity, and ground. It's important to achieve the desired product, which is the ability to bear and manage load effectively. So in this case, socket serves as the interface between the user limb and the prosthetic leg. And the primary function is to provide a secure and comfortable fit. Next is the connecting shaft. The connecting shaft is used to connect the socket to the knee joint and the foot, transferring forces and providing structural support. And knee joint is responsible for flexion and extension, allowing the prosthetic leg to adapt to change in terrain and provide a natural walking pattern. And the foot component is interact directly with the ground and providing stability, shock absorption, and propulsion during walking and other activity. So the foot design should consider the environmental condition to ensure its durability and provide optimal support. Next, we move on to the cause and effect diagram. And the cause and effect diagram highlight the comfort issue, excessive weight, and the functional limitation of prosthetic leg. And this can result in various negative effects such as skin irritation, socket design and fit, and the difficulty in controlling movement, limited adaptability to different terrain, and irregular gait pattern. And this effect can collectively discourage the individual within the disability community from using prosthetic leg as frequently or effectively as they would like, impacting the overall quality of life and mobility. And this is very important for us to address the cause and improving the prosthetic leg design and functionality to enhance their acceptance and use within the disability community. Next will be the 340 principle. So if the prosthetic leg is stronger, the prosthetic leg might be more reliable to the user, but the weight of the prosthetic leg will be increased. So in this case, we improving the parameter will be reliability 27 and worsening or preserve will be the weight of the moving object. So by using the 340 principle, the action will be change from uniform to composite material that are lighter, stronger, and more controllable. And second, if the prosthetic leg is more functional, the stability of the prosthetic leg will be higher, but the volume of the foot might be larger. So in this case, we improve the stability, but the volume of the stationary object will be increased, which is the volume of the foot. So by using the 340 principle, By using the 340 principle, we enhance the design by our study. We have three conceptual design, which is conceptual design 1, conceptual design 2, and conceptual design 3, which show in this slide. So this is our final product. This is the isotomal view, the 2D drawing, top view, side view, and front view. And this is the 3D drawing of the final product. And this is the exploder view. So conclusion, in summary, the application of conflict resolution principle from TRIZ theory to prosthetic leg design focus on the innovation in three critical areas, which is comfort, weight, and functionality. So TRIZ encourage us to identify and resolve conflict in comfort by considering the cushioning mechanism or adjustable feature that can provide a more comfortable and tailored fit. So TRIZ also suggests resolving this conflict, resolving the heavy weight of the prosthetic leg by exploring lightweight material or weight distribution strategy. So for the functional issue, the TRIZ principle helps us to address the functional conflict by exploring novel mechanism, advanced control system, or adaptive technology. So that is all from me. Thank you.